And welcome to today's webinar, co-hosted by ourselves and Scottish Engineering. So today's webinar looks at developing talent in the engineering sector. My name is David Aaron. I'm the Marketing and Communications Manager for the Graduate Apprenticeships team here at Heriot-Watt. Before I just go through some quick housekeeping, I'm going to recap on today's running order. So we're delighted today to be joined by John Campbell of Scottish Engineering. John's going to give us an update on the engineering and manufacturing sector in Scotland, including a look at the critical skills challenge facing employers just now. Next up, after that, from Heriot-Watt, we've got Lynn Somerville, one of our business relationship managers, and Alan Faulkner-Jones. And Alan is the programme director for our engineering, design and manufacture programme. Lynn and Alan will give us an overview of graduate apprenticeship programmes here at Heriot-Watt. After Lynn and Alan, we're delighted today to be joined by some of our colleagues from one of our key employer partners, Raytheon UK. We've got Scott Gray and Steve Fortune. So Lynn's going to host a Q&A with Scott and Steve, as they share their graduate apprenticeship experiences from a Raytheon perspective. So that's the running order. Before we start, just some quick housekeeping, as I mentioned. So today's session is being recorded. If you could switch off your cameras and mics during the presentations, that'd be great. And at the end of the presentations and the Q&A, you'll be able to ask all of the panel any questions you like. So you can either do that verbally or by using the chat function. So with that done, it just leaves me now just to hand over to our first speaker, John. Over to you, John.
Thanks, David, and thanks again for the opportunity to share this with you and to give a short presentation. And my name's John Campbell from Scottish Engineering. My background is power engineering, and I now work with the team at Scottish Engineering. And I'll just jump on to the next slide, David, please. Thanks. Just very briefly, Scottish Engineering is industry membership body for engineering and manufacturing in Scotland. We have over 400 members across every subsector within engineering and manufacturing you can think of. We offer connections, member networking. We support members with services. We speak out on their behalf as the voice of engineering, and we work on that STEM skills agenda, which of course is very critical at the moment, has been for a while. And finally, we are owned and governed by our members, and we're a not-for-profit organisation. Next slide, please, David. Thanks. Just again, very briefly, we cover all the main industrial supply chains across Scotland and our support networks with membership, for example, with academia, Heriot-Watt being an example. In particular, we have a lot of membership in aerospace, defence, maritime and energy, and we cover every type of organisation, fabricators, precision, digital tech, etc. So that's really who we are, and I'll just move in now to the next slide, David. Thanks. Big picture for our sector, of course, is the sort of macroeconomic outlook, and on that front, I've borrowed a couple of charts here from the Bank of England, from their policy report in May, and of course the two key features that I think most people will be aware of is that post-COVID economic recovery has stalled, and we're looking at a period over the next 2 to 3 years of basically zero growth. Unfortunately, for a whole lot of reasons, and we're also looking, as you can see in the chart on the right, at a period of exceptionally high inflation, the highest for over 40 years, and I think one for a manufacturing and engineering perspective, one particular feature of that is the energy cost component, which is shown on the right-hand chart as the purple bar. And you can see that that is having, that energy component is a large part of inflationary costs. And of course, this the war in Ukraine is exacerbating these inflationary pressures, and it is contributing to the stall in economic output and across Europe and the world. It is particularly impacting energy cost inflation, and we know that the full implications of the Ukraine war are as yet unclear. So that is the rather difficult combination of economic stagnation and inflation that our sector faces. But of course, the picture is much more complicated than that, and I'll move on to the next slide. We in Scottish Engineering, we survey our members every quarter on key measures that they are facing, and I do see a lot of economic reports from academia, in particular from government. Quite often, I'm amazed to see that some of the data they're using goes back 1 year, 2 years. This is absolutely up to date. So this is what our sector are telling us, or what our membership are telling us just in the last 2 to 3 weeks. And the response rate was high, maybe 130 member companies, so certainly statistically valid. And we asked them about key measures such as order intake, output, their export expectations, their staffing levels, their investment. You can see that we have been on quite a steep V-shaped recovery from the COVID period. And up until the last quarter, that was progressively more positive, but you can see that the positivity is maybe tailing off. I mentioned evidence of headwinds. That's one way of putting it. And business optimism is still positive. Everything is still in positive territory, but you can see that perhaps the direction is heading the other way, which isn't surprising in the economic circumstances we find ourselves in. The only one that is still going up there is staffing, which we'll come back to. Recruitment and skill still being probably the #1 issue that we see across our sector. So that's really where we're at. Recovery from COVID continues, but unfortunately tailing off. If I move to the next slide, David. Common themes. So we talk to between us, we're a small team, but between us we talk to dozens of members every week. We meet them, and this is what they're telling us. These are the sort of common themes that come up again and again and again. And on the positive side, as I've said, still positivity in terms of order books and outlook, but that degree of optimism is unfortunately declining. On the good news, some of the sectors that perhaps were affected by COVID, particularly, such as oil and gas and aerospace and automotive. A lot of positivity there, despite supply chain issues, and of course defence remains, certainly for our membership, remains very positive. And we do see growth areas. We see that in the membership we're taking in as well. Some of a lot of new members in recent months from the space, renewables, digital side, and companies looking at other types of decarbonisation projects, including hydrogen. The only question marks there will be about capacity in the Scottish economy to accommodate, for example, the offshore wind initiatives that are due to come through over the next over the next decade. Other key theme we see, companies more so than ever are talking about diversification. some who who had perhaps had their fingers burned from over reliance on any one sector, particularly through COVID. Others who are just looking at the trends in environmental and carbon targets, net zero, and looking for new opportunities. But we do see a lot of members looking to diversify their order book and their customer base, particularly into areas such as renewables. And the last sort of positive trend, I'd like to call it, I'm certainly not suggesting that we're seeing a reversal of 50 years of price-led globalization, but we do hear time and time again member companies telling us that they are looking to bring back supply chain onshore to Scotland or the UK. They're looking to, in many cases, insource production processes that had previously been outsourced overseas. They're looking for local content, and that is a response to some of the pressures, the geopolitics, logistics, price. It's also about managing quality and consistency, and that's got to be a positive trend. On the challenges front, number one on the list, time and time again, people shortages, skills shortages, and I'll come back to that in the next slide. But other pressures, you will not be surprised to hear huge increases in pressure on material costs, on input costs, and availability. Energy costs in some cases 3 or 4 times higher, moving from maybe 2 or 3 year fixed deals to the new market reality. And of course that's putting margins under significant pressure. Logistics still a global problem, and certainly not assisted by the war in Europe. And of course, for many, there are still issues around the Brexit hangover. And that roadmap to net zero to meet the UK and Scottish government targets for decarbonisation is a real challenge for companies. It's also an opportunity. It appears on both sides. And the final challenge, companies here in Scotland lag behind the UK in their adaptation of automation, digital solutions, cobots, etc. And the UK itself lags our major competitor nations. So I guess it's a challenge to catch up. It's also an opportunity. But these are the themes that we hear time and time again. Just moving on to the next. Thanks, David. Like I said, skills is usually number one issue, and it's a limiting factor for many companies. And by that I mean that additional production line, that new site they're looking at, or bringing in new machinery, or putting on an extra shift, or meeting contracts and target times. And those are the areas that are being limited by the lack of skills, and the lack of skills takes many forms. Welders is one I've heard mentioned a lot recently in the technical skills sense, and moving on to the sort of graduate engineering side, and perhaps the most relevant to this session, what members tell us again, time and time again, is that the core engineering disciplines, whether it's mechanical or aerospace, electronics, civil, electrical, these are still hugely valued, but they're looking for more. They're looking, and the only way I can describe it is overlays. They're looking for people who have an appreciation and understanding of how data and digital skills can be applied in the manufacturing and engineering process, or the manufacturing environment. They're looking for people who understand what net zero is about in the context of engineering, and circularity and sustainability and product design, and usability and resource efficiency. And perhaps of most interest from my perspective they're looking for people who have that blend of skills that go above and beyond the basic engineering knowledge base, that these meta skills or work ready skills. And I'm no expert in this field, but the sorts of areas I hear discuss: innovation, critical thinking, social intelligence, and leadership and interpersonal skills. And those are the, as I say, the overlays. And we asked our members in a recent survey some questions about the recruitment of graduates and apprentices, and most of them, 81%, as from the top point here, told us they were able to recruit, which is good. Only 19% had issues recruiting to fill their advertised positions. However, 23% of the respondees said that they found that their graduates and apprentices didn't subsequently demonstrate the desired skills for the position, the basic engineering skills. Much more tellingly, though, almost half said that their graduates and apprentices did not demonstrate these work-ready skills and meta skills that I mentioned earlier. And that, of course, is where we certainly strongly back the graduate apprenticeship programs as being part of the solution, particularly particularly based on what our members are telling us, and we certainly see a lot of desire out there in the sector for more funding, and we see growing interest in this whole area. So that's really me, David. I hope that gives some relevant lead in to what's to follow.
Yeah, absolutely, John. Thank you very much. Just some contact details on the screen, and obviously we'll send the slides round post-event, and if anybody wants to get in touch, I dare say you'll be happy for them to do so.
Absolutely delighted to hear from anyone.
Good stuff. Thanks, John. Thanks for that. That's some really great insight there. So that nice little link on graduate apprenticeships takes us nicely on to Lynn and Alan, and they're going to cover off their graduate apprenticeships. Lynn.
Thanks, John. Thanks, David. So my name is Lynn Somerville. I'm a business relationship manager on the graduate apprenticeship programme at Heriot-Watt. So my role at the university is to work with employers to help them to bridge skills gaps and to succession plan by upskilling or reskilling their current workforce, or to help them to recruit new talent to their organisation. So as John highlighted in his presentation, recruitment and skills shortages being the number one concern for employers sat within the engineering sector. The Scottish Government see the GA programme as that strategic way for employers to address these issues, ultimately driving, addressing these issues, ultimately driving economic growth across Scotland at the same time. If you'd like to go to the first slide, thanks. So since its inception over 200 years ago, Heriot-Watt has been pushing the boundaries of education, developing new ways to build skills and share knowledge through traditional and non-traditional means. So approximately 50% of our students are classified as being non-traditional, learning remotely through a variety of flexible education provisions and work-based learning opportunities. So some interesting facts to note: that Heriot-Watt produces more CEOs than any other learning institute in Scotland. We have over 350 companies in Scotland, where employers are benefiting from the wide range of upskilling and reskilling options that we provide through Heriot-Watt Online. 95% of our graduates are in employment or further study within 6 months of graduation, and 47% of graduate apprentices achieve a first-class honours degree. If you'd like to go on to the next slide. Thanks, David. So Heriot-Watt is a truly international university. We have 5 campuses globally, with a campus in Edinburgh, one in Orkney, one in the Borders, and we also have campuses in Dubai and Malaysia. Across these campuses, we have over 30,000 students studying with us. We have research and education partners in 150 countries around the world, and we have a huge alumni network with over 147,000 alumni in 190 countries. You'd like to go on to the next slide. Thanks, David. So the Graduate Apprenticeship Programme is a groundbreaking initiative that offers employers a rather unique opportunity to bridge skills gaps and succession plan by creating a degree qualified workforce. It's also a rather unique way for the GA candidate, graduate apprentice candidate, to gain an honours degree qualification whilst employed and being paid to work in a role that is relevant to the discipline of the degree itself. So graduate apprentices are ideal for both new and existing employees, and they're an excellent tool for attracting new talent into an organisation, as well as being a fantastic way to upskill and reskill existing employees who are looking to develop their skill set and enhance their career prospects. Importantly for the student and the employer, it is fully funded by the Scottish Funding Council, meaning there's no additional cost for either party. The employer is simply responsible for paying the GA candidate's salary. So graduate apprenticeships form part of the wider apprenticeship family alongside the foundation and modern apprenticeships. The difference being graduate apprenticeships simply deliver at a higher academic level than the FA and MA programmes. They're also the natural route for progression for those candidates who've already completed a foundation or modern apprenticeship. So a graduate apprenticeship is not just about doing a part-time degree. The GA programme integrates work-based learning and academic activities against the learning outcomes of the degree itself, meaning that what the person does in their job can be credit-bearing and can be cross-mapped to meeting the academic requirements of their qualification. And Alan will get into more detail on that in his presentation. But for that reason alone, we have had many part-time undergrad candidates swap on to the graduate apprenticeship programme. So alongside the work-based learning, the student will spend time during the working week on academic learning. This can either be on campus or remotely, meaning that we can support employers in remote locations across Scotland and candidates who are unable to come onto the campus for whatever the reason. There are two very important roles, support roles, who work simultaneously in support of a graduate apprentice candidate. One is the workplace employer mentor, and the other is the Heriot-Watt personal tutor. These roles are critical in supporting the GA candidate to keep on track and to achieve the degree. The Heriot-Watt offers free mentor skills training in support of our employer mentors, and we work to support the triad setup between the GA candidate, employer mentor, and the personal tutor, working closely together in support of the GA candidate throughout the duration of the GA programme. Next slide, thanks. So who are the GAs for? One of the great things about the graduate apprenticeship programme is that it's open to people of all ages. There is no upper age limit as to who can apply, and in fact we're proud to say that we have people of all ages and from all levels of seniority from organisations both large and small on the GA programmes that we deliver. Prospective GA candidates can be anyone over the age of 16 who live and work in Scotland, and prospective students can either apply via their employer or they can find available opportunities via the SDS website apprenticeships.scot. For employers, the GA programme is available in support of any employer in Scotland looking to widen their talent pool, address skills gaps and succession plan, and future-proof their workforce development plans. Employers would speak with me directly, and I would offer tailored recruitment support in advice of their needs. Okay, so I think you've moved on to the next slide already. So typically the GA programme is a 4-year programme unless the candidate is applicable for advanced entry to year 2 or year 3. We consider recognised or accredited prior learning such as HNC, HND, and your foundation and modern apprenticeships, as mentioned. And as also mentioned, the graduate apprenticeship is a unique combination of both work-based learning and academic learning, so the 80% and the 20%. Again, Alan's going to get into a little bit more detail on that, but the 20% at Heriot-Watt is 1 day per week where the candidate will be required to attend classes, be it fully online, in person, or a hybrid of both. This 1 day will always either be a Friday or a Monday, depending on what year the candidate enters the programme. And this 1 day must be included in the candidate's contracted hours of work, i.e. the employer is paying the candidate to attend university and to achieve that degree. Next slide, thanks, David. So this slide shows the results of an employer survey undertaken by Skills Development Scotland, and you will see from the results employers give graduate apprenticeships a very firm endorsement. We're going to send these slides round after the presentation so you can have a little closer look at those slides at that point. Can we go on to the next slide? Thanks, David. So you'll see from this slide a small selection of the employer partners that we've been working with since we started delivering GAs in 2017. So we're proud to say that we work with companies of all different sizes, from micros right through to household names. If we can go on to the next slide. Thanks, David. So lastly, this is a list of the 9 GA programmes that we currently deliver against. Again, my colleague Alan will get into more detail in relation to the engineering-led programmes. And again, these slides will be sent around and these are hyperlinked, so you can click through to the full GA description at your leisure. But that's me for now. I'm happy to take questions at the end. Thanks for taking the time to listen.
Like you to take over. Hello, everyone. So I'm Alan Faulkner-Jones, as mentioned at the beginning. So I'm going to be concentrating on the engineering GA programs that are listed on this slide for this portion of the talk. So you can see here we've got 3 frameworks, although we've split the engineering, design and manufacture framework into 2 programs at the university. So we have a full mechanical engineering focused program, and we also have an electronic and electrical engineering program as well. And alongside these 2 main programs, we also run the engineering instrumentation, measurement and control, and there's the data science program there as well, which we run out of the same school. Next, please, David. So in terms of how these programs work at Heriot-Watt University, we've got the good 1, 2, 3, 4 model here. So it's one day a week of timetable classes. Obviously, this used to be on campus, just like the undergraduates not doing a GA program. But now, obviously, we've moved to a hybrid delivery model. So these students can come to campus if they want and sit in the classrooms with the instructors, or they can be online and view the classes remotely. The classes are also recorded, so if the students miss them for whatever reason, they can catch up. And it also means that if they were in the class and just want to refresh their knowledge, the recording's there for them to refer back to. On top of that, 1 day a week, there's also a requirement for 4 hours of additional study through the working week, which can be arranged however works for you and your apprentices. It could be a single 4-hour block, 4 1-hour blocks, half an hour here, half an hour there. It doesn't matter as long as they get that, and that's really key to tie the 2 different halves of their working life together, the requirements of their job role and the requirements of the GA program as well. So tying these 2 together and formulating their work into blocks of evidence that can be submitted against program outcomes. 2 is that there's less than or equal to 2 what we call core courses every year. So these are courses which very strongly resemble your traditional undergraduate courses with fixed assessments that everyone does the same, and lectures at the university with no work-based component to them. But then, of course, the majority of the rest of the year is work-based programs. There's also 2, because there's 2 supporting people for each apprentice. There's the work-based mentor in the workplace, and there's a personal tutor assigned at the university. For 3, this is another difference between the GA and the traditional programs. It's 3 semesters, which I know doesn't really work as a word construct. Semester meaning 2, but we have 3. So we have the traditional semester from September to December, semester 1, and then we have semester 2 from January to April, May, and then we have a new semester just for the GAs starting from May to the end of July. So we cover about 40 weeks of the year. We have the traditional breaks for winter and spring, and there is still a summer break, but obviously it's shorter, being only August and half of September. For 4, it's a 4-year program. So unlike other routes to get an honours degree, rather than the traditional way, this gets you there in the same amount of time. So rather than doing a part-time program, this is still a full-time program. Next slide, please, David. So in terms of monitoring them, we don't just set the students off and let them go in an unstructured fashion. We want to keep on track and make sure everyone's doing okay. So we have a quarterly review process, or at least as a minimum quarterly. We can have as many of these as is needed in the individual apprentices situations. So at least 4 meetings a year with the apprentice, their personal tutor, and their work-based mentor to monitor their progress. So check what it is they're being learned, what experiences are in the workplace, and then how these two things can be tied together. And then obviously this leads on to a portfolio of evidence that the apprentices will be amassing as these two things are tied together, which fundamentally is a demonstration of how the GA framework outcomes are being met by the apprentice. And we have a structured document for those of you who are familiar with how modern apprenticeships work and are familiar with the unit specifications. We have a course specification, which is structured along the same lines with the requirements of evidences for each course and the learning outcomes that will be met by meeting these. And there's also suggested activities, and in lower year courses, there's lists of knowledge and skills items of which the apprentice only has to choose a subset. And the balance of these are being met with past tests and similar fixed coursework that are worth a maximum of 20% of the course. So 80% of the courses at a minimum are still work-based. And in order to track all of these going on through the year, we've got an individual learning plan and an individual learning agreement with goals that are set between these meetings to provide structure to the year. Next slide, please. So in terms of entry, there's many different routes through to the GA, which is the turquoise box towards the right there. And there's many different points of entry. So as Lynn said, obviously there's the standard entry point at year 1. There's also direct entry available at year 2, and in extreme cases or exceptional cases, year 3 entry is also possible. And we look at a variety of different entry points and qualifications that different people may have. We sort of have a wide range of different routes that people can adopt in order to get to where we need them to be. And there's lots of different qualifications, too many to list here. So we have a sort of catch-all at the end there, which is just the combination of credits at a particular level with the number of points. And obviously maths is very much required in this to enable them to build as a foundation for them to build on in the later years. We find that the students who struggle the most are the students who didn't have the maths. So we make it a requirement that they need the maths. And to help them get there, we have maths diagnostics, which we can put our candidates through. So if you've got a candidate in mind for the apprenticeships, we can issue them with a diagnostic test to check their level of comfort with math concepts that they would need for that entry point. And then if they fall a bit short, then we have a maths masterclass over the summer, which will be able to get them there. So say if they haven't got higher maths, so it's level 6, but they have got Nat 5, for example, or they've got a bit of a more shaky higher maths, then we can give them the masterclass to get them up to the level where we're sure we can use that. Similarly, if they've come in from an HN qualification and they don't have sufficient maths there, so engineering maths 1 and 2, if they've only got maths 1, then that's something that we can patch with the maths masterclass. And as you can see, it's a continuum of qualifications. So this is a Bachelor of Engineering with honours degree. We can then build on that with a Master of Science, MSc, and then that leads obviously on to PhDs and engineering doctorates as well, if the apprentices so wish. Next slide, please, David. So this is the program on one page at a glance, so quite a high level of abstraction. And you can see the distinction there between the core courses at the top for each year and the work-based courses on the bottom. So you've got a lot of maths at the beginning, as you'd expect, 4 courses worth of maths in the mechanical program. And then from years 3 and 4, then we've got core engineering design and engineering manufacture courses, which are co-taught with the undergraduate doing the traditional non-GA degrees. So they get to mix with those and do group activities, which is useful. And then all the courses on the bottom you can see are the work-based courses, which are at least 80% work-based, if not more. So the quite a few of these courses, the purple ones, are more closely 100% work-based learning. So your design and manufacture skills and practice-based courses. So starting in year 1 with your sort of hand tools and basic drawing, into second year where you've got machine tools and CAD drawing, and then it proceeds through there. So automated tools and 3D CAD and simulations and that kind of thing. And then you can see all the basic courses that you'd expect from a mechanical engineering focused degree. So your strength and materials, mechanics courses, also basic electrical engineering, thermodynamics, fluids, thermo, again. And these courses starting from year 2 become more optional. So you're really able to direct the skills required for your individual apprentice and then mold them into the specific skill set and expertise that you require of your graduate by the time they reach the end of the program. So you need 8 courses in each year. Courses are fixed size, so you can see the individual project and the employer-based activity are worth more than 1 course. So you choose 2 optional courses in year 2 and 2 optional courses in year 3. Next slide, please, David. And then there's a similar structure for the electronic version of the program, where we have the same 4 maths courses, and then there's different courses, obviously, not engineering, design and manufacture, but there's probability and statistics, and then semiconductor electronics. And in the 4th year for the core courses, they get to choose between the advanced topics shown at the bottom there. And then for the work-based courses, first year is almost identical. There's only 1 course different. The mechanical engineers do thermofluids, and the electronic engineers do digital logic and systems in the 2nd semester. So if an apprentice decides, or if the company decides that they want to go a different way with the apprentice, it makes it easier to change between the 2 programs. And then similar amount of courses in there. You've got the optional courses in electronics. It's choose 1 of the work-based courses as an option. But you can see there's some shared courses there. So operations management, project management, and business awareness was shared between the 2 courses as well. Next slide, please, David. Then we have the engineering instrumentation, measurement and control program, which is slightly different, but works on a similar process. So we've got 3 of the 4 maths courses as core, and then there's a process modeling course in year 3, and then there's a lot of work-based courses again with options as you proceed through the program. Next slide, please. Oh yeah, and there's case studies for a lot of these. So we've included 3 examples here of students. So Lucas was among our first graduates from SCOT Mass Group, and Laura started the program in 2017 as well, but in first year. So she graduated last year. And then we've got case studies, obviously, from Raytheon, and there's several more. And these 3 blue buttons are hyperlinks, so that you can read those at your leisure. That's me.
Thanks, Alan.
Questions later.
Great stuff. Thanks very much. So, Lynn, I think what I'll do is I shall stop sharing, and we can now hand over to your good self, who's going to do a bit of a Q&A with Steve and Scott from Raytheon. Thank you.
Brilliant. Thanks, Alan. Hi, Steve. Hi, Scott. How are you doing?
Good, thanks, Lynn.
Good, good. So, as one of Heriot-Watt's strategic employers, Raytheon are going to have, it'll be 20 spaces, GA spaces, come this September. So I'm really quite excited to ask Steve and Scott some questions So Steve, I'll probably start with yourself. Could you maybe tell us what the key reasons the graduate apprenticeship model suits Raytheon as a business and what benefits it brings to your organisation?
Yeah, sure. So, yeah, like you said, we've been working with Heriot-Watt on graduate apprentices for 4 years now. We'll get our first apprentices graduating this summer, so we're excited about that. And the reasons we first started looking into this were similar with things John mentioned earlier, the skill shortages. Within Raytheon, we had an ageing workforce, so we had a demographic challenge, and the graduate apprentices were first of all able to offer the degree courses that we were looking at, so the academic side of the specific theory and disciplines that we were looking at. But the fact that it was also linked in with the work-based learning meant that the graduates, apprentices that joined us were able to learn really specific skills to the areas that we work in. So the types of machinery that we work in, the types of products that we work with. And that meant that we were able to, or hoping to able to backfill positions that needed those specific skills. So that was really good. The benefits we've seen so far are that the graduate apprentices that have joined us are really excellent in terms of their rate of learning. So they pick things up really fast, so they can contribute to the business really quite quickly after joining us. Also, it's really a good thing for attracting the best talent. So the graduate apprenticeship, as Alan went through, is really appealing to people looking to get a degree because they can, they've got a salary while they go through that. They're getting the same honours degree that a traditional undergraduate would get, and they're getting work experience through it as well. So because it's such an appealing prospect, it means as we offer these places, we can hopefully attract the best talent as well.
That's quite a poignant point. I think more and more candidates are looking at employers holistically in terms of how they do support their employees. So it probably allows you to attract that kind of higher caliber of candidate as well, doesn't it? Because you are seen to be investing in your staff. It's maybe a good time to ask Scott a quick question about the role that he does within Raytheon. So Scott, do you maybe mind telling us which GA programme you're currently studying and what year you're in your job role, etc.?
Yeah, so I work, I'm studying the Engineering, Design and Manufacture course. So that fits in quite well with what I'm working on in Raytheon, which is test engineering. So we'll manufacture a product and then it comes to us and then we'll test it. And it's just doing a sort of functional test, seeing if it works, seeing if there's any issues, seeing if we can fix those issues, and then signing it off and then delivering it to a customer. So with my university work, that sort of, it blends it nicely to where I'm studying sort of the electronic side of it, and it adds sort of a base level to what we're working on.
Have you found a situation where you've not been doing anything in the workplace and the university's had to support you in a kind of simulation type scenario?
I think the university has sort of given us the tools to use for simulations. So sort of like MATLAB we use a lot in university, and that's helped quite a lot with simulations. And also there's one called Falstad, which also is sort of a circuit simulator. So those have helped quite nicely with the sort of the AC circuit side of it. Those are the only two that I can really think of that have applied.
That's good. That's good to hear that. And maybe jumping back to you, Steve, maybe with that in mind and kind of overall the GA study and how that's made a positive contribution to the workplace. Do you have any examples that you can maybe offer?
In terms of how they've
been able to use
contributions.
Yeah, their contribution, yeah, to the workplace.
Yeah. So first of all, they make a positive contribution to the real products and production lines that we've got going. So as our graduate apprentices progress through the the 4-year course, the levels of accountability that we can give them increases. So we've got our 4th years now that are actually becoming subject matter experts for some of our key pieces of kit. So they're performing live roles and they're able to help with that resourcing issue that we might have. But really from day one, they bring in fresh ideas. They are able to bring in some of the problem solving and improvement ideas that our business needs in terms of that fresh impetus. And they're also good at becoming STEM ambassadors and helping with our STEM outreach programs as well. So we've got that people that are fresh in that, coming straight from school or coming from within our production line and doing some upskilling. So they're able to help share those ideas and help encourage the next generation of engineers and technicians as well.
That's really good to hear. That's one of the things that SDS reports on, that whole innovative thinking and fresh thoughts being brought into an organisation. Scott, can you maybe give us a little bit of background as to what you were doing before you joined Raytheon in the graduate apprenticeship? Was it an upskill, reskill? Were you already with Raytheon, or did you join direct from school or college?
So I just came out of high school. So I was thinking about what I was going to do after high school, and it was should I go to university and go through the traditional method, or should I go do something else? And I felt like doing an apprenticeship was sort of the best of both worlds, where I could get the work experience in what I wanted to do and also get a degree that was a full-time degree, a proper degree. So it was just the best opportunity for me, I would say.
How did you find out about the opportunity? So
I think it was a website called Scottish Apprenticeships or something like that. The school told me about it, so I just looked through that and saw a couple that I liked, and Raytheon seemed to be the one that sort of ticked all my boxes, we'll say.
That's apprenticeships.scot, it would have been.
That'll be the one.
Yeah, so that's good to hear. So how do you find balancing work and studying towards a degree? What are your main challenges?
So it's a bit difficult, just because it's a full-time degree and a full-time job, essentially. It's sort of difficult to have that balance, but since we've got that day release, it's quite easy to fit all the work in, and we've also got that 4-hour time and during the week to spend on some of the course. What are they called? Sort of the work-based learning stuff that we've got to do. So it's we've got some time allocated in the week to sort of work on what we need to do.
So how important do you see the role of the employer mentor and the personal tutor in supporting you in that? Is that quite key, do you think?
I think so. I'm not really that good at writing reports, so it's good to have sort of a mentor to sort of read through it and say, okay, you're on the right track, you need to add something here, sort of thing. So that's been quite good, and also sort of just sort of a career mentor as well, saying like what I should do in Raytheon, where I should go in Raytheon. So I feel like it's been quite a useful thing to have.
That's a really good example, because no one's great at everything. So it's a really good example of where the employer mentor and personal tutor can be there to support a candidate. So, I mean, is there any specific examples that you can offer where you've been able to apply your learning in the workplace, like your theoretical learning from the university?
I think most of the stuff that we learn in university is sort of it's a building block to what we're doing in work. And right now we're working on some air traffic control and global sensor stuff. So it's using a lot of radio frequency, which is like on another level. It's like black magic compared to the stuff that we're doing at uni. So it sort of gives a good building block sort of learning to set me off. And now that I'm in my 3rd year, it's sort of balancing quite well, and it's blended together quite well with the electronics that we're using at work.
Yeah, that sounds exciting. And all in all, how would you sum up your GE experience so far, and would you recommend it to others?
It's been really good. I would say it's a lot of work to balance the university and the work side, but I would really recommend it to anybody, just because you get that work experience, actually real life work experience, working in the subject. So I would highly recommend it.
Okay. Thanks, Scott. Steve, probably one last question for you. Could you maybe tell us what Heriot-Watt's strengths are as a graduate apprenticeship provider?
Yeah, so from my experience, the strengths mainly is so that the courses that they deliver is really good and suitable for companies like Raytheon. So that's first and foremost, they offer the exact courses that we're looking for. The quality of these courses are really good, but mainly the communication and feedback aspect's been really positive as well in our experience. So whether it's the course tutors that are letting us know how things are going, and maybe us being able to give them some input in terms of what extra subjects we would like to see included if possible, as we've kind of worked together to get the content correct, or whether it's been through yourself or your colleagues, Lynn, checking in with the company and finding out that how we're finding it, if there's any issues, if there's anything that either the company or the university could do better. So there's that constant feedback loop that's able to keep things hopefully being successful for everyone involved. So that'd be the main things I'd say so far.
That's really positive. We do take industry feedback seriously. Ultimately, that helps to shape what we do deliver. So thanks, Steve. That's really positive. So thanks for both taking the time to chat. David, I'll hand back to you.
Sure.
Thanks.
I think, yeah, so we've got, listen, thanks Lynn, and thanks Steve, and thanks Scott. That was really great to hear that feedback. So yeah, it sounds like well, we're not going to chat it because it does work well for that model, works well for Raytheon. So it's really good to hear that directly from yourselves. So we do have a few minutes left for some questions for the whole panel. So I think John's still on the call. We've got Lynn and Steve and Scott and Alan as well, obviously. So if anybody would like to ask a question, that would be amazing because you've got access to all these people. So I know, Sarah, you have put a question in for Alan, just in terms of how much data or digital skills are delivered within the programme. Alan, is that something you could, or Sarah, do you want to expand on that question? Is there a specific thing in there?
I was really following up on one of the points that John made about, delivering training that went beyond the actual core engineering program and encompass some of the skills that are really in high demand, and how we were approaching that. And if there was examples Alan could give of how students were learning to use data in some of their processes and practices, and keeping those skills up to date.
Yeah, absolutely. So it's something that we're very aware of, and we do embed. So you won't find a course called data science or anything within our program, because we sort of do it as needed. So there's an activity that those students do in first year on data analysis and presentation. So either we give them some data or they supply some data from the workplace, and then we sort of guide them with the best way of how you would present that, and then what information you'd extract from that. And then that sort of builds up in second and third year, and for all of the other courses where data is involved, which is engineering, data is everywhere. It's very much a kind of, this might be new now, so this is the next bit about what you would do. This is some more advanced analysis you would do. This is more information about how you would get something out of this. It's like, it's not just data anymore. What is it? It's a relationship. What can you get from this? What confidence do you have in the data? So it's like slowly building up in each of the project courses that they do throughout the program.
No, that's great. Thank you. And I did want to say to everybody, it's been really interesting session. So I've really enjoyed it. But Alan, I think that's maybe something just that we could talk about in terms of surfacing that more, just so that people understand that they're getting those skills, or that they're available through our programs. So thank you.
Yeah, there's a whole strand of points in there which are useful things to have, which we don't necessarily signpost because they're part of other courses. So it would be great to have sort of some courses that just go, oh, this is your engineering ethics, this is your accountancy, and this is like all of the data skills are all in one place. But because we don't want to teach it all in one block, we want to get it in. Similarly with the maths, it's sort of you do it as a strand throughout the whole thing. It's sometimes difficult to point exactly at where it is. But it's there. It's just sort of woven through the structure.
Great, thank you.
Thanks, Alan. Thanks, Sarah. Good question. So there's nothing else in the chat just now. Is there anyone on the call that would like to ask the panel a question? Just while you're having a little think about that, just to sort of cover off so what we'll do is we'll obviously send round a copy of the slides today, and we'll also send round a link to the recording of the session so that you can share that with your colleagues, or you can watch it again if you're so inclined. So just when I don't know, Alan, if you get any other observations to make just now, or John, or whatever, just while we're waiting, I'll just give it a wee minute or so if anyone else wants to ask a question. But if there's any sort of closing observations, we've got a minute or two.
Just one comment. Stephen mentioned that the experience at Raytheon is that graduate apprenticeships are quicker in terms of establishing themselves and making a contribution, and that is exactly backs up the feedback that we get from a number of companies that use GAs, that graduate apprenticeships, our graduate apprentices are able to, and perhaps it's by definition because of the nature of their working role in the company, but the feedback is certainly very clear that these people are much quicker in terms of being productive and assimilating with the team, becoming an effective member of the team. So I just wanted to back that up and say very similar observation from a whole number of companies. And if there's somebody else waiting to come in, I'll shut up.
Okay.
Also, just back to the point that that Alan was talking about, these data skills, for example, and environmental, green, net zero skills. I take your point, Alan, that you try to encapsulate these into the coursework rather than them becoming. I would promote that as very strongly, and maybe you do because I haven't seen all your materials, but employers really want to hear that because they do tell us that they are looking for evidence that their graduates are thinking about these themes and can apply them in the manufacturing, engineering process, whatever environment. And I would kind of shout out about that a bit and promote it to them, because they want to hear that and they want to know. And I think I spoke to one university, not yourselves, recently, who said that they had absolutely no environmental, green, circular, anything like that built into their engineering courses.
Wow.
And I think I think if you do, you should promote it because it is a selling point.
Thanks, Sean. Thanks, Finn. Listen, we've got one quick question from Dirk just come in. It's just, I think, Alan, for you, you kind of covered it before. When will real live lectures start? Understanding is that they're still only done virtually, which I think.
So as of last January, we moved from online to hybrid. So some students were asked, and some students weren't. So for certain courses which were quite small, individual students were asked whether or not they were likely to come to campus before we decided one way or the other. But for the large classes, some of them stayed online. But the majority of classes from January have been hybrid. So the lecturer has been in the classroom and the students have been invited to attend if they wish, or to attend online. And that's the way we're going from September as well. Certain courses, which are still quite large, are online, but the vast majority will be available on campus. And we're booking rooms for those online courses anyway, so that the students can stay, if they're on campus, they can stay in the same classroom. They don't have to go and find space elsewhere in the university. And it means that they're meeting each other. They're having those sort of sideways chats during classes that we've missed during the pandemic, and the community of the studying is coming back, which has been something that's been really hard to replicate during the pandemic when everyone's been remote. No one, well, very few students have their cameras on, which is fine, and not all of them use their microphones. So we've had a bunch of a cohort through now who up until January, well, still some of them actually, because they're geographically dispersed. Heriot-Watt has quite a global, it does, but in the GA, it's national. We have quite a national reach now when we have apprentices as far away as the Shetland Islands. So distance isn't an option, isn't a barrier to them carrying on with their studies, and we've minimised to the point of a very small points here and there where they actually have to come to campus. Even in engineering programs, there's no points where they have to come to campus, but there are a few points we recommend that if they're having trouble finding things in their workplace, then they can, and we've really squeezed those into set points during the year. So it is possible to go one end of the extreme to the other. You can attend the program almost as we used to, where everyone comes to campus and sits in the same classroom and undertakes the same work, but with the benefits of the past few years now, where everything is recorded and you can come in online, or you just review it later, or you can go the other way and stay in that online only mode, and that works just as well for the students. And we've had feedback from this last semester, in semester 2, that students in both groups have enjoyed it and they've got just as much out of it in either direction. So this is the way we're carrying on.
Thanks, Alan. Hi, Sarah.
Hi, sorry, one last question there, Alan, on that. I mean, it's really good to hear, and I appreciate that the great value in being able to deliver the GA program to people across the whole country. You know, and you mentioned Shetland, and I know that John and Scottish Engineering are really involved in the whole offshore renewables and all the people that will be required to work in those areas. Are you able to also guarantee that the assessment part of those years would be delivered online, or do students have to come to the campus to do final examinations?
That's a great point. I can't believe this has to be the first one of these that I've forgotten to mention it. There are no exams in these programs. We've got rid of them. So in the mechanical engineering program, there are no exams at all. There is one optional exam which students can take if they want for their own professional development. In project management course within our program is separately accredited by the Association of Project Management. So students can elect to take that exam at the end if they wish to get the associated qualification. But in the mechanical program, no exams, absolutely no requirement for the students to come to campus if they don't need to. Class tests are all online, and obviously the main component, their portfolio of evidence, that's all submitted through our online environment, Canvas, in whatever format they want, reports, videos, all the rest of it. So that's all done. Electrical or electronic program, it very much depends on which optional courses they take in the 4th year as to whether or not there is an exam for those courses. But we are making sure that there is a route similar to what we're doing at the moment, where the students can do all those remotely and not have to come to campus. But yeah, that's, you know, it's a minimal amount of work, and we can pretty much assume that at this point that that's not going to be an issue. And we would never ask students to come that distance just for small things like that. I mean, it's a 2-hour exam and you're spending how long in transit to get here to do it?
2 days, maybe?
Yeah. For some students, yeah.
Yeah.
So yeah,
okay, thank you.
There's processes in place for that.
Excellent. Thanks, Alan. Thanks, Sarah. So we're slightly over. So if there's no other questions, I'll just like to thank again our panel today. Thanks, John. Thanks, Steve and Scott from Raytheon. thanks Lynn and Alan, and thanks to everybody that turned up today. So as I said, we'll get the information out post-event, and it was great to see you all today. So thanks very much. Thank you.
Thanks, David. Thanks, everyone. Have a good day.